In this video, we're going to look at how do we create probability distributions along with finding the mean and standard deviation of a probability distribution. So for this scenario, we're going to pretend that we're having 4 kids and our random variable is going to be looking at the number of ways that we can have a boy. So let's just think about it. If we have 4 kids, we could have 0 boys, we could have 1, we could have 2, 3, or all 4 boys. So there are 5 different values for our random variable x, and our random variable is just counting the number of ways that we could have boys if we have 4 kids. So if we have 0 boys, that means we have girl, 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 and then another girl. We have all girls. If we have 1 boy, the boy could be born first, so we have boy, girl, 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 or the boy could be born second, or third, or fourth. So there's lots of different ways that we could have 1 boy with 3 girls. If we have 2 boys, well, there's even more. We could have girl, girl, boy, boy, or we could have girl, boy, or girl, boy, boy, girl. So we can also have boy, boy, girl, girl, boy, girl, girl, boy, or let's see, boy, girl, girl. Are there any more? I think that's all of them. If we have 3 boys, the boys could come first and then the girl, or the girl could come at any point in the lineup. Or if we have 4 boys, that means we have boy, 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 boy. So let's see, how many is that? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've come up with 16 possibilities, and if we go back to our rules from probability that tell us the size of our sample space, well, we have 4 different events. We have child 1, child 2, child 3, and child 4, and each child there's 2 options, either boy or girl, boy or girl, boy or girl, or boy and girl. So the size of our sample space should be 2 times 2 times 2 times 2, which is 16, and we came up with 16 possibilities, so we know that we've come up with all of them, so we're good. So to make our probability distribution, we list out all possible values of our random variable x. So 0 boys, 1, 2, 3, or 4 boys. And then we need to find the probability for each one. Well, there's 1 way out of the 16 to have 0 boys. There are 4 ways out of the 16 to have 1 boy. There are, 6 ways out of 16 to have 2 boys. 4 out of 16 to have 3 boys. And 1 out of 16 to have 4 boys. So there's 2 conditions for a probability distribution. The first condition is that all the probabilities have to be between 0 and 1, which they are. And the second condition is that the probabilities need to sum to 1. So let's check that. They do indeed sum to 1, so this is a good, proper probability distribution. Often, we want to know what is the mean of a probability distribution. And with Excel, this is actually pretty easy. We cannot use the function wizard function average to find the mean of a probability distribution. Oh goodness, where'd my computer screen go? All right, there it is. I don't know if y'all saw my screen just went black, but it's back. All right, so we cannot use the function wizard function average to find the mean of a probability distribution because that only works for data points. We don't have data points here, we actually have a distribution. So we're going to have to do it by hand using the formula. But it's really not so bad with Excel. So the formula to find the mean of a probability distribution is the sum of x times p of x. So let's create a column that calculates x times p of x first. So for this, I'm going to take each of my x values and multiply it times the p of x values. So I'm just doing x times p of x, and then I'll drag that down. And then to find the mean of the probability distribution, all I have to do is sum my x times p of x column. So this is our mean. This 2 represents our mean. And this tells us if we have 4 kids, we would expect 2 of them to be boys, which means 2 of them would be girls. And that makes sense. We know that because there's like a 50-50 chance of having a boy or a girl, it makes sense that if you have 4, you would expect about 2 of them to be a girl and 2 of them to be a boy. One other thing is that if you're trying to calculate the expected value, that's the exact same thing as the mean. Expected value just tells you what you would expect to happen, which is what you would have happen on average. So the expected value is just another way to say the mean. Sometimes we also want to know the standard deviation or variance of a probability distribution. And again, we can't use the stdev.p or s functions. Those don't work because we don't have data. This is a probability distribution. So the way we find the variance of a probability distribution is, again, we use our formula. We start off by calculating a column that calculates x minus mu, then squares it, and then multiplies it times p of x. With cell references, this isn't too bad. So we're going to do equals parenthesis, then click on your x, minus, and I'm going to actually type in my value for mu. That's 2. That's the average of our distribution. We found that down here. So we've got x minus mu squared times, and then multiply it times your p of x. So we're just using the formula and using cell references to calculate that for each one. So x minus mu squared times p of x. Then drag it down. And then to actually find the variance, we sum that column. So 1 represents our variance. Let me make it look kind of pretty here. Everything's better when your Excel sheet's nice and organized. All right, so 1 is our variance. That is the sum of x minus mu squared times p of x. And then to get standard deviation, all we do is we take the square root of variance. So the square root function in Excel is equals sqrt, parenthesis, and then whatever you want to find the square root of in parentheses. So we'll do equals square root, so referencing that variance cell, and that is our standard deviation. And so it's a little bit boring in this case because our variance was 1, and the square root of 1 is 1, so it didn't change. But usually you'll have a number with some decimals, and when you take the square root of it, it is a different number. And so what's nice about this is the empirical rules that we learned back in, I guess that was chapter 2, they still apply. So this is telling us that the mean is 2, and our standard deviation is 1. So if you go out 1 standard deviation from the mean, so down to 1 and up to 3, so somewhere between 1 and 3, you'll find most of your data, about 68% of your data. So standard deviation means the same thing. It's telling us how far away from average we have to go to find most of our data. And then the last thing is if we want to turn this into a chart, we can start by highlighting our probabilities. This is just like we used to do relative frequency histograms. Create a column chart. Make it a little bit smaller so we can see everything. Try to get up here. See, I'm going to change my chart layout to layout 8 so that the bars touch. I'm going to label this my random variable values. And up here we have our probabilities. And this is representing, let's see, number of boys. And then I need to change my horizontal axis. I'm going to right click, select data, edit my horizontal axis labels. I want to change them to my random variable values. And then right click and click on add data labels to actually get the height of each bar label. So there we have a nice histogram or a bar chart showing us our probability distribution. We can see that the average, or the typical number of boys, is 2. Most of the data is within 1 standard deviation, and it actually forms a nice bell shape.